Assalamualaikum warahmatullahi wabarakatuh. My name is Dalila Binti Ismail. Today I will present about the mini project of renewable energy system entitled Design of a Grid Connected PV Power System for Residential Application in Turkey. Renewable energy that may be used to produce electricity, provide hot water, heat and cool a home, and provide lighting for commercial and residential structure. Sun has been the primary source of energy on Earth. Solar energy is the radiation from the sun that is absorbed by the Earth. Most significant of Turkey's several potential sources of alternative environmentally friendly forms of energy. Turkey has a greater possibility of success than any of the other nations in terms of the potential of solar. Turkey has a solar potential of 26.4 million tons in the form of thermal energy and 8.8 million tons in the forms of electricity. Turkey is exposed to an amount of sunshine that is nearly 11,000 times more than the whole quantity of power that was produced in Turkey in the year 1996. Photovoltaic system as well as solar thermal system are both capable of being used to great purpose. Renewable energy source that is expanding at one of the highest rate globally. Amount of solar energy that is able to reach the earth may be used to create electric power, and the potential for using solar power in large-scale application has significantly increased over the last few years. Solar PV and solar thermal technologies are used to a significant degree now, and there is very indication that this trend will continue in the foreseeable future. Next, the background study. Solar energy has recently been receiving an increased amount of attention and debate in the Turkish media. It's not a terrible thing to bring up the topic of solar energy on the agenda on a regular basis. Nevertheless, does not suggest that the issues that are associated with this subject have been totally handled. It will provide a concise explanation as to why Turkey, one of the sunniest nations in Europe, has not been able to achieve the essential breakthrough in solar energy, and then it will outline the several significant problems that are now being faced by the sector. The problem statement for this mini project is Turkey's economy has a significant vulnerability in the area of the energy. Second one, fast rising incomes in industry, which has resulted in a matching growth in the need for energy. The third one is limited reserve of fossil fuel, and as a result, it must depend on import to meet the majority of its energy requirement. And the last one is results in significant expenses to the economy. Next is the meteorological data analysis and load profile. Before installing a solar PV, the initial work is to identify and analyze the meteorological data. This data include time, temperature, solar irradiation, and PSH peak sun hour. Table below show the meteorological data in Cankiri, Turkey. For monthly average, the highest temperature is in August, where the value is 24.71 degrees Celsius, and the lowest temperature is in February, where the average temperature is 1.804 degrees Celsius. Meanwhile, for solar irradiation, the highest solar energy stored is in August. Figure below shows the monthly average temperature and solar irradiation of year 2021. The bar graph below shows the average temperature for each month starting from January until December. This data taken is used for further work, which is calculation for solar PV. The calculation involved is to determine how many modules on the roof that required for the house. Next, the graph shows the solar irradiation for each month. It can see that the highest solar irradiation can get is in August. Since this country is four-season country, therefore, in August, the season is summer. That is the reason why in August, the solar irradiation is the highest. Here is the residential load profile in Cankiri, Turkey. So, the total power consumption per month is 761 and 17 kilowatt hour. Next one is the design of the proposed PV system. We started with the designation of the PV system. So, from the meteorological data that have been obtained, the value of energy required per year equal to 9,134.04 kilowatt hour, and the PSH period equal to 1,513. Start with the calculation of the power, and then proceed with the calculation of number of modules, and then the inverter sizing. So here is the PV system power that have been calculated, and the power that have been used for this system is 8 kilowatt. Meanwhile, the number of modules that have been used for this PV system is 21 modules. The inverter sizing indicate by the value K. So the phenomenal inverter is equal to 7.6 kilowatt. Here is the calculation of the number of modules in series based on open circuit voltage. So the V open circuit equal to 49.585 volt. The number of modules in series based on open circuit voltage is given as below. So the number of series is 20 maximum unit in series. Okay, here is the number of string can be estimated as the formula below. So all the parameters required for the calculation are collected from the datasheet of the inverter and PV panel. So the number of string is 1 string per MPPT. Here is the detail of the string and the string. So the inverter has 2 MPPT tracker and has 2 input per MPPT. So the total input is 4. Consider one string is 4 string. So the optimal size of inverter is 29.76. So we can conclude that the number of inverter used is 1 inverter. So it is possible to conclude that the total number of PV module installed in Cankiri residential will be 21 panels and 1 inverter. Okay. As mentioned in the datasheet, the length of the PV module is 1.956 and the width is 0.992 and the height is 0.036. So the panel area is equal to 1.9462. We have to consider the mandatory gap between panels, which is 0.02 mm. As mentioned in the datasheet, we can calculate the net area needed, which is 40.87 meters square. And from the datasheet, the weight of the PV module is 90.5 kg, and the roof weight required has been calculated, and it get 409.5 kg. Okay. By selecting a rooftop area of 40.87 meters square and a capacity of 409 kg, so the total number of solar panels that can be connected in series parallel is 21. So here is the panel when arranged horizontally, and this is the panel when it's arranged vertically. Okay, here is the one line diagram. One line diagram is used to design a solar PV installation which details the main component used within the system. It uses single line to show how they are connected. As shown in the figure, the one line diagram designed to propose for a residential house in Cankiri, Turkey. Based on the calculation, the maximum of module can be installed is 80 modules. However, only 21 module is drawn based on the number of module needed for the house. Next is costing analysis of the PV system. So at this stage, we have to calculate the return of investment. So it must start with the capital investment, which is 25,870 ringgit Malaysia, the total cost for PV solar panel per unit and also the inverter. And it proceed with the annual cost saving for solar panel. And we will get the return of investment, which is 4 years and 2 months. So the selected PV panel is monocrystalline type, which has maximum power at 385 watt. So the proposed power for the PV system is 8 kilowatt, which result in the building to use 21 module in this installation. Then for the inverter sizing system, the selected model and brand proposed in the system is suitable to be installed with the 21 module of PV system, because when an inverter that is slightly larger than the suggested value, the power delivered to the grid will be limited, resulting in the waste of energy. So from the analysis of ROI, it will be estimated that about 4 years and 2 months from the starting of investment. As a conclusion, this many projects are designed the PV system at Cankiri, Turkey. So from that we can conclude that after appropriate meteorological data and daily load profile, PV system component size can finally be obtained, and we can create a renewable energy at the Cankiri, Turkey. That's all from me. Thank you.